Assalamu alaikum class. In this lecture we will discuss the fourth way of traversing a binary tree, that is level order traversal. Till now we have discussed three traversal techniques: in order, pre-order and post-order. All of them were recursive technique. But there is yet another way of traversing a binary tree that is not related to recursive traversal procedure. In level order traversal, we visit the nodes at each level before proceeding to the next level. At each level, we visit the nodes in the left to right order. How we are going to print all the elements in a tree in level order traversal? We will start from the root node, and the root node here is 14, that is at level 0. We are going to print its value, and then we move downward toward the next level, that is level 1. And now we will print all the values at level 1 while moving from left to right. First we are going to print 4 and then 15. Now at the next level there are 3 nodes, 3, 9, 18. We are going to print all these nodes while moving from left to right. First we will print 3, then 9 and then 18. At the next level there are also 3 nodes, 7, 16 and 20. We are going to print all these nodes, first 7, then 16 and then 20. At the last level or the depth of this tree there are only 2 nodes, 5 and 17, and we are going to print these nodes while moving from left to right. First we are going to print 5 and then 17. The first question that may arise on your mind that how we are going to program level order traversal. It may seem difficult, but its implementation is simple, using non-recursive method by using queue instead of stack. A queue is a FIFO, first in, first out structure, which can make the level order traversal easier. Here is the implementation of level order traversal. The name of the method is level order and it is accepting a pointer of type tree node, which will be pointing to the first node or the root node of the tree. In this line, we are creating an object of queue because we need queue, and the queue will be containing the nodes of the tree, and with each node the element of type int. If the tree node pointer passed to the function is pointing to null or null PTR, in case if it is null, there is no need to traverse and the method will return. If tree node is not null, then the very first node pointed by the tree node pointer will be added in the queue, and that will be a root node. Next, there is a while loop which runs until the queue does not become empty. As we have recently added only one element, so the condition in this loop is true now. Inside the loop, dequeue method is called to remove one node from the queue that we have entered before entering the loop. The element at front is taken out and the return value will be a pointer to a tree node. In the next line, the int value inside the node is taken out by using getInfo method and printed. Now we will check if the left subtree of the tree node is present. If it is not equal to null, then we are going to enqueue it into the queue. Similarly, we see if the right subtree of the node is there. If yes, then it is inserted into the queue. And this process will continue until the queue becomes empty. Now we will execute level order traversal by hand on the tree shown in this figure to get better understanding how level order works. We can see that the root node of the tree is containing element 14. This node is inserted in the queue first. After insertion of node containing number 14, we reach the while loop statement where this is taken out from the queue and element 14 is printed. Next, the left and right subtrees are inserted in the queue and these are 4 and 15. Now the control is transferred again to the start of the while loop. This time the node containing number 4 is taken out because it is the front element of the queue. Now we will print 4 and then its left and right nodes will be inserted into the queue. In this queue, number 15, 3 and 9 have been inserted until now. We came back to the while loop starting point again and dequeued a node from the queue, and that will be 15. First, the number 15 is printed and then we checked for its left and right child. There is no left child of the node with number 15, but the right child is there. Right child is the node containing number 18, so this number is inserted in the queue. In the next iteration, 3 will be dequeued. Now we will print 3. As you can see, there is no left or right child of node 3. So, no new node is inserted in the queue in this iteration. In the next iteration, we take out the node containing number 9. Print it on the output and look for its left subtree. It is there, hence inserted in the queue. There is no right subtree of node 9. Now we take out 18 and print it. After printing, we will insert its left and right node into the queue, that is 16 and 20. Now we take out 7 and we're going to print it. After printing 7, we will in queue its left and right child. Its left child is 5. 5 is inserted into the queue and its right child is empty. Next element is 16. We're going to print 16 and insert its left and right child. There is no left child and its right child is 17 and 17 is inserted into the queue. Now we dequeue 20 and 20 is printed. There is no left or right child of node 20, so no new node will be inserted in this iteration. Now we take out 5 and print it. There is no left or right child. No new node will be included in this iteration. Now we will dequeue 17 and print it. There is no left or right child of node 17, so no new node will be inserted. Now queue has gone empty, while loop will be terminated, and you can see we have printed the 3 node elements in the level order.